Hey there, welcome to Learning Labs. Today we're in Unit 3, we're talking physics. Specifically today, we are on Chapter 1, which is all about force and motion. What is force? Oh, what the heck is that? Jeez, moving that took a lot of force. That's what force is. Force is something that causes an object to move, change direction, speed, or shape. So for example, right there, I had to use force to move that thing out of the way. I changed its direction. There's another type of force. How about this? I can squish this thing, changing its shape into that. I've used force, a lot of force, to change its shape from its original thing to this. All right. The way we can think about force is a push or pull on something for the specifics of Chapter 1 in Grade 6 Science. You can describe a force by talking about its strength and its direction. So when I was pushing that object, I was using a certain amount of strength measured in newtons, or capital N, okay? So strength is measured in newtons, but I'm also measuring the direction. So I'm pushing an object. I'm using a certain amount of force to push it, but I'm also pushing it in a certain direction. These are the two factors when we're talking about force and motion. A couple of ways we're going to get into it later on, but when we're talking strength, we use N for newtons, and when we're talking direction, we're using an arrow. Couple types of forces here. We got contact forces, which is something like friction or touch. So that was me pushing an object. You also have non-contact forces like gravity or magnetism. These two will jump in later. Here we have some types of forces. Friction force, as we saw before. If you take a look at the snowman going down the hill, you have its force and direction going, this way, down the hill, but you have friction working against it in the red arrows, pushing it away. Now, if the forces were equal and the arrows are equal, it looks like they're equal here, the snowman would stop because the forces are balanced. Me pushing against an object, if it's pushing back just enough, we're gonna stay here at a halt. If the blue arrows are longer, meaning more force than the red arrows, then the snowman will continue to go because friction is not stronger than the force of going down the hill. We have gravity, applied force that's pushing something. We have a spring force, drag force. This is really cool. I love it when we get into aerospace. We got magnetic force, and then electric force. We're gonna be only talking about 5 main forces: gravity, friction, weight, air resistance, and upthrust. Take a look at this picture. Do you see any types of forces going on here? I see a couple. Let's start with Jay. What's that little guy doing? He's pulling something. Remember, force is push or pull, right? So he's pulling his little toy. Let's look at Kay, his parent. They're pushing a stroller. Gravity. The only way to fly as a human is to work against gravity. What is gravity? Gravity is a force that pulls objects downwards towards the center of the earth. Now, if you've watched our astronomy unit, you know a thing or two about gravity and how it keeps planets in its orbit. So gravity here in physics, what we're talking about, is the force acting on all objects on Earth, pulling it down to Earth, keeping everybody on Earth. Now this force, gravity, can be measured. We use weight. Now, gravity is an acceleration. Oh, we're getting a little bit fancy here. Stay with me. Acceleration due to gravity is 9.8 meters per second. What does that mean? An object falling from the sky will fall towards Earth at an acceleration rate, so how fast, of 9.8 meters per second. So every second it's falling, it goes 9.8 meters. Just like how when you're driving a car, it says you're going 50 kilometers per hour. This is talking 9.8 meters per second. Force, so the gravity is the force. Force equals mass times acceleration, or shorthand is F equals ma. Mass times acceleration. So everything has mass, as you learned in our astronomy unit. To figure out how much force it has, if it's moving, we times it by the acceleration. So me, I have mass. If I'm walking from here to here, to figure out the force of which I'm walking, you need to times my mass by how fast I'm moving. And that's how you find your force. Your units of measurement for force, again, is newtons with a capital N. Now on Earth, there's always friction, no matter what. So you walk in here, you're resisting gravity, you're also resisting air. You're falling from the sky, you're resisting by also air. If something falls in a vacuum space where there is no air, the only force acting on it is gravity. When there's no resistance, it's called fluid friction. When air resistance equals gravity, when something's falling with gravity's force, and it equals the same amount of force of the air resistance, it's called terminal velocity, meaning that's as fast as that object will go. It will no longer go any faster. You've reached its maximum speed. Check out this video.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
No way. The astronaut was on space, in space, on the moon, and he had a hammer and a feather, and he dropped it at the same time. Now on Earth, if you do that, the hammer will hit the ground long before the feather even reaches the ground. The reason why is because the hammer goes through the air resistance a lot faster. Air resistance works on the feather and it slows it down. On the moon, however, there is no air resistance because there's no atmosphere. Therefore, it is in the fluid friction that we talked about earlier. So they go at the same acceleration just based on gravity. There is no resistance to slow one or the other down to change its speed. Take a look at this. We got mass and weight. What is mass and what is weight? Are they the same? Are they different? Now, back in my years, I always got these guys confused. I finally figured it out. Mass is the amount of matter anything contains. Okay, it's usually measured in grams or kilograms. This is not a force. However, weight is a force caused by gravity pulling down on the mass of an object. It's measured in newtons. Weight can change. Mass cannot change. So weight equals mass times acceleration. Weight is a force. Remember we talked about how force equals mass times acceleration? Same thing. Might be still confused. How does mass not change but weight changes? Well, look at the example on the moon. The masses of both objects did not change. The mass of the hammer, mass of the feather, they were the same as they went up to the moon versus on Earth. However, when they dropped, they landed at different speeds because the weight changed. The weight on the moon versus the weight on Earth. Friction is the resistance between two surfaces that are in contact with each other. Why does rough space have more friction than a smooth space? Let's take a look at this diagram here. We have a small push with low friction on a smooth surface. And the guy, he's able to push it no problem. However, we look over here, we have a rough surface and a bigger push and a bigger resistance. Why does this happen? Well, rough surfaces have small grooves in them, like little teeth. Now, if you know anything about dinosaurs or sharks, their teeth are like grips, like hooks. So when they grab their prey, they can't squirm out. If their teeth were flat and smooth, it would slip right out. So think of the rough surface like this. It's got teeth and it's grabbing the box. And it's making it hard for the guy to push the box. So he needs to give a bigger push because the higher friction. See, every force has an equal force against it. So if I'm pushing this way, the friction is pushing this way. And if we're not moving, meaning I'm pushing as hard as I can and we're not moving, that means friction force is equal to whatever I'm pushing. If we're moving, that means I am stronger than friction, so my arrow would be bigger and the box would move. Friction part 2, types of friction. As you can see, there's a couple types of friction. We have static, which acts on objects that are not moving. Say I had a desk here. Let's plop it in. Boom, there it is. Now I'm pushing this desk. Right off the get-go, it's not moving and I'm not moving, and we're just at the standstill, and I'm about to push it. That's static friction. Notice when you try to move something without momentum, it's always harder right off the bat. But once you start pushing that desk like this, then we get that momentum and it's nice and easy. Sliding friction. When two solid surfaces slide over each other, like bicycle brakes. So if you ever seen how your brakes work on your bike, there's a little claw. It's like this. Your wheel spins through it, and when you hit the brakes, it squeezes on the wheel. That friction slides while the brake is holding onto the wheel, and it squeezes it, creating friction and slowing it down. It's like grabbing the wheel and slowing down slowly. That's why if you press the brakes really hard and it grabs it really hard, the wheel locks up. Rolling friction. When an object rolls across a surface, so like skateboarding. Now, if you ever jumped on a skateboard, you have to keep doing this thing with your leg. I don't know if you can see it, but why do you have to keep doing that? Because if you pushed once and you kept rolling, that means there was no friction and you rolled on forever. Since there's rolling friction, you have to keep pushing because the friction slows you down. It is a force against you. And then you have fluid friction. When a solid object moves through a fluid, so in your car, you have a bunch of moving parts in there, probably the piston moving up and down. It's in a cylinder block, and the cylinder moves up and down, and there's metal walls around it. Now, if you imagine metal on metal, that's a lot of friction. Eventually, it's gonna wear down, and the engine's not gonna be any good use. So how do we avoid that? We throw some oil in there. Now the oil is between the two metals, and it allows less friction. There's still friction, there's fluid friction, but a lot less of it. It allows smooth friction. It's like that smooth surface.
с бывшим Советским Союзом. Они также продвигают инициативы включить в НАТО Грузию и Украину.
What you just saw was called hydroplaning. What is hydroplaning? Well, this is what the answer is to this question. What does water do to friction? Fluid friction, as we saw with the engine and the piston, it reduces friction. Okay, there's still a little bit of friction, but it's a lot less. So when you're driving on the road and there's a lot of water, a lot of fluid, it reduces your traction and the friction and the grip on the road and allows your car to spin freely. Hydroplaning, very cool. Air resistance. Air resistance pushes against things which are moving. So check this out. Which surface has greater friction, the rocket or the parachute? Now, you should probably already know this one. Air resistance, the parachute, of course, has greater friction. It has greater air resistance because it's a big like net catching a bunch of air. And that air is the friction. It's pushing against it. That's why we use parachutes, so we can land safely. The rocket, on the other hand, is very thin and cuts through the air like a knife. That's its purpose. It's trying to leave the atmosphere. It needs the least amount of resistance because it's trying to cut through it all to get to outer space. If there was a bunch of resistance pushing against it, it needs more rocket fuel to counter that force and really push really hard to get out of the atmosphere. All right, since we're talking about rockets, check this out. This is upthrust. Upthrust is another type of force. It pushes an object up. Okay? It makes it seem to lose weight in a fluid. Fluid is either liquid or gas. Okay, so gas meaning air or water. When a force works on an object, there are always another force working on it as well from the opposite direction. So check out this. This is a force graph. Okay? It shows all the forces working on an object at a single time. So you have baby robot. He's pushing up the ramp. You have normal force pushing up, how much it weighs, and you have gravity pushing down. Okay, so 9.8 meters per second pushing down. You have the robot's force of pushing, and then you have the friction force of pushing against. So each force has an equal and opposite force on it as well. Up, down, left, and right. The way we know where something moves is then we ask how much force. So if the yellow arrow had more force, the robot's pushing stronger than the red force, which is friction, we know the box is moving that way. If the robot was pushing less than friction, plus gravity is working more than the normal force, then we know the box is moving backwards and the robot's gonna get crushed by the box. Upthrust, you can always think about thrusting of a rocket ship. Combining forces. So just like how we talked about with the net force graph, showing all the action going on, net force is a combination of all these forces acting on an object at one time. We can say that it's balanced or unbalanced. A balanced equation, if you can think about a seesaw, if we're balanced on both sides sides, we don't move. We're balanced. But if it's unbalanced, one side has moved. One side goes down and one side goes up. That's how you can think about balanced and unbalanced. So balanced forces are forces that cancel each other out. They don't change an object's direction or motion. Forces equal in size and opposite in direction. Okay, so if I'm pushing the box, if I'm pushing 100 newtons and its friction is pushing 100 newtons back, we're at a standstill, we're equal forces, we're balanced, we're not moving. I'm gonna need somebody else, maybe my brother, he's gonna come in and help me out. Now we got 100 plus 100, that's 200 newtons. That overpowers the 100 newton friction, we can move the box. Unbalanced forces, it's when a force causes change in an object's motion. Force in one direction is greater. So me and my brother, we team up, that's 200 newtons. Boom, we push the box. Unbalanced force. Check out this example right here. Tug of war. When we were doing tug of war on sports day, it was tied up. We were tied. It was 300 newtons. And then Mr. Ram pulled out the big guns. And then it was easy win, 500 newtons. We won that. Here's some more examples. All right, that's chapter 1. I know it was a long chapter, forces in motion, but it is opening us up to all our cool experiments on our way.